You're most welcome, members. This time we are going to talk about diffusion, which refers to the movement of particles from a region of high concentration to a region of low concentration. And we are going to use this simulation here, where if we have 40 particles, 40 blue balls on this side of the container, we know that they are freely moving. If we remove the divider and allow them to freely move, we shall realize that because they are colliding with one another, some of them will have to cross to the other side, and this goes on until when they are uniformly distributed. That's why at some point you realize that the blue balls on the left hand side of the container and the right hand side of the container are almost equal. That's what we call diffusion. Diffusion is affected by a number of factors, one of which is temperature, and in this case we are going to have 30 balls on the left hand side and 30 balls on the right hand side. The red ones are 30, the blue ones are 30. We vary the temperature and make the temperature of the blue balls very low. If you look at it, you realize that their speed has also slowed down, while the temperature of the red balls is 300 Kelvin. If you remove the divider and allow them to freely move into the different corners or different sides of the container, after a given period of time we stop it and check our data, we realize that where we had a lower temperature, only 2 balls have crossed to the right hand side, and where we had a higher temperature, up to 15 balls have managed to cross to the left hand side. That is one of the factors. The second factor is concentration. Let us vary concentration by making 20 balls this side and we make it 60 balls to the other side. We check ourselves after a few seconds to find out how many balls will have crossed the divider. We allow it to go on, and if we stop it, then we check where the concentration was low, where there were few balls, only 3 have managed to cross, and where there were many, up to 32 balls have crossed. That is the second factor. The factor of temperature can also be looked at in liquids. Look at this situation whereby we have water, and to the water we are adding potassium permanganate crystals. The potassium permanganate crystals dissolve and distribute the purple color all through the water to make it look purple because of diffusion. Now we vary the temperature of the 3 containers here at 0 degrees Celsius, 20 degrees Celsius and 70 degrees Celsius. Then we also add potassium permanganate crystals in those containers at those temperatures. Then we find out what happens. If you look at this, after a very short period of time, actually something like 10 minutes, the one where we had 70 degrees Celsius is highly purple, the purple color has highly distributed itself into the water because diffusion is higher at a higher temperature. And where we had 20 degrees Celsius, you see the water is still a bit faint, meaning that diffusion occurs at is low at that lower temperature. And where it is 0 degrees Celsius, we can see almost the particles of potassium permanganate are settled at the bottom, and up here there is nothing like the purple color. So thank you.